Alright, so now we can go and extend and say we've broken down this element, this structure into two elements, and now we want to say, well, what we know what we can do is we can go and compute the stiffness matrix for each element. So I can say for element 1, we can essentially have our element in this local psi world, if you recall, where this node is essentially -1, this node is associated with 1, and this is where psi is equal to 0. So I can map this element towards this world. This is what we've learned now. And again, this is just associated with node 1, x1, x2, x3. This is just where the mesh nodes fall for that. Okay. Remember when we had these elements, we always had a convention to say, look, this element will always number as node number 1, 2, 3. Okay, so I'm just what I'm going to do is call this the local numbering. The local numbering. Okay, and so locally we always said that this was node 1, this was node 2, and node 3 was always in the middle. And that helped us when we had our small stiffness matrix that we computed for this element, because now I've got everything that I can go and compute this stiffness matrix. I know where the x's are, and I have this local numbering of 1, 2, 3. So this has told me that there's a force balance at this node, force balance at this node, force balance at this node for each of the rows, and then each of the columns is the unknown associated with this. So in this local system, so I'm going to call it maybe Q1, and I'm going to put a bar on top to distinguish it from the Q's here, which is the Q's in this global system, Q1, Q2, Q3. And then this was associated with variable Q1 bar, Q2 bar, and Q3 bar. Okay. But what we know is that Q1 bar is, as a matter of fact, is actually associated with Q1. So I can say here Q1 bar is associated with Q1. Okay. Q3 bar is actually associated with Q2. Q3 bar is associated with Q2. Hope that's big enough. Ooh, just. Q2 bar. Q2 is associated with Q3 in the global system. Okay? And all I'm doing is I'm just saying if I take this element that's here with the Q1, I say this is the same associated with this is associated with this, and this is associated with this. There I know more or less how to associate it now. Okay, and also what I can say is in terms of the local numbering, this 1, 2, 3, we essentially have association with the global systems of 1. So 1 to 1, locally 3 will be associated with global 2, local 2 will be associated with global 3. Okay, that's what we have there. So what I can do is, maybe I just shift this a little bit to the side. So I'll just wipe this off and just shift this to the side. So this is Q1 bar, Q2 bar, Q3 bar, and this is 1, 2, 3. And what I'm going to do is I'm going to put a like this, and I'm going to call this the local. So locally this is the variables, and locally this is the node numbers. Okay. And globally I could also say then there's also associated global node number and variables. So globally this is associated with Q1. So this is what the G refers to now, is that we also look at where the stiffness matrix fits in the global system. We've got Q3 is associated with Q2, Q3 bar, Q2 bar is associated with Q3. Can you see that? That's essentially what we have there. And then lastly what we have is also in the global scale, local 1 is associated with global 1. Local 3 is associated with global 2. So local 3 is associated with global 2, and local 2 is associated with global 3. That's all. So now we've got that sorted out as well. And so the beauty of this is, once we've done this, is that we now nicely understand that if I were to compute this stiffness matrix by saying, let's say this is A, B, C, D, E, F, this will be D, this will be E, this will be F because of symmetry, that this stiffness matrix needs to slot somewhere in here. Okay. And what I have now is I've got this stiffness matrix where I know what is the local numbering, and I know what is the mapping from the local to the global numbering with the variables as well. So what I can say then is this local the first, let's say, local force equilibrium at node 1 associated with Q1 must go into the global force balance at 1 associated with Q1. So that's where the A must go in. So that's essentially just 1 Q1, 1 Q1. It's where A goes in. If I look at this one, I say this is still, this local 1 will remain in the global 1, but now Q2 bar, so this D, must go into the Q3 position in the global 1. Okay, so this Q2 bar is associated with Q3. So that's where the D will go in. And then Q3 locally, which is this one, the third column, must go into the second position in the global 1. And that's that. And then I can say, fantastic, second row in this local stiffness matrix must be going to the third row in the global 1. So it must go into this row. Okay, Q1, a bar is associated with Q1, so that will just stay there. That's the D. Second row, Q2 bar, go into the Q3 position, Q2 bar. So the second column of local thing will go into the third in the global 1, so that's where the B will go. And then lastly, this last one is essentially Q3 bar, third column in this stiffness matrix locally will go to the second position in the global stiffness matrix. That's what we have there. And then I can say the third row of this local stiffness matrix is associated with the second row in the global, so it will go in there. And so this is again Q1 bar will go into Q1, that will be the E. Q2 bar, the second column here, this F, will go into the third position, and then the C will go into the second position. And there's my stiffness matrix. Okay, that's one element. I'm going to stop the video here, and we're going to do the second element. Okay.